Okay, guys, hello. I just thought let us take an hour from 11 to 12 to answer this test paper. It's a grade 10 formal test, past paper 2025, but I guess it has the following topics in it, right? So, a 50 mark or 55 mark question paper should take us an hour to write, right? So hopefully we can write it from 11 to 12. That's 1 hour. And we go to sleep. So let us then tentatively say at about 12:15 we should be finished, done. If any of you are in grade 10, please drop a message in the chat if you haven't as of yet written test 1 of the control test for the term. But if you have written the control test for grade 10 already, boo-hoo-hoo to you. Alright, and hopefully topic-wise, if there are topics that you feel like, I don't know what topics you guys are writing on. If you haven't written, okay. Only Sinat, you're writing maths paper 2 on Monday. Only Sinat, you're writing maths paper 2 on Monday. Are you talking about grade 10? So I've written paper 1. What topics are you writing on? That's paper 2 on Monday. Only see Notai. What are the topics for paper 2? For you, that is. Okay, you grade 10, but like what are the topics you'll be writing on? Because I'm guessing you're done with paper 1, so you're writing test 1 on the 27th. Oh, Archive of Milani. What are the topics for test 1 on the 27th, Archive of Milan? Alright, because like I said, I'm doing a past paper, grade 10. Okay, this was September 2025, last year's paper. So I'm going to do it for an hour, guys, from now 11 up until 12. Okay, I'm going to quickly just bounce through it. Alright, move from one question to the other. Hopefully, if the topics don't resonate with the topics that you'll be writing, like, unfortunate, guys, but let us begin. Let us begin. Right, let us begin. Okay. Yeah, typical instructions, guys. Question paper consists of 6 questions. Answer all the questions. Number your answers correctly according to the number system used in this question paper. Of course, that is always true. Please show all calculations, diagrams, graphs, etc. that you have used in determining answers. Answers only will not necessarily be awarded full marks. An approved scientific calculator may be used unless stated otherwise. If necessary, round off answers to 2 decimal unless stated otherwise. Diagrams are not necessary to round to scale. An information sheet with formula is included at the end of the question paper. Good for them. To write neatly and legibly. Good for them. Question 1.4, 5.3. And 6.1 must be done on the diagram sheet on pages 7 and 8. Okay, first question there. You can see we have functions exponential. That is, okay, so let's look at it. The function f of x is equal to b to the power x plus 2. From the get-go, we are very much vigilant that any exponential function is actually supposed to be in the form ab to the power x plus 2. So that b is carrying the exponent x is fine. That means there's an a value that we need to be aware of, and that is 1. That's the one that comes before b, so that's a. So a is equal to 1. We know that for sure. So we are told that f of x is equal to 1bx, 1b to the power x plus 2 passes to the point p, 2 and 0. So this is the x-intercept, of course. because y is 0, x is 2, that's the coordinates of the y-intercept, and has the horizontal asymptote of at y is equal to -9. Horizontal asymptote, that tells us something. We know that when we talk about horizontal asymptote, we are talking about q. Furthermore, it is given that b is greater than 0. So this value here, the variable b, should be greater than 0. And we are also told that b cannot be 1. Right? So the question then is, write down the range of f for 3 freaking good marks. Guys, what is the range of f? So f of x, I repeat again, is 1b to the power x plus 2, passing through the point P, 2 and 0, and has the horizontal asymptote at y is equal to -9. Furthermore, it is given that b is greater than 0, b cannot be 1. Guys, here's some few things. A is equal to 1, meaning a is greater than 0. That means the function here is found above the asymptote. Whenever a for the exponential function is greater than 0, that means our function can be found above the asymptote. Okay, I repeat, whenever a is greater than 0, then the function is found above the asymptote. But if a was less than 0, meaning the coefficient, the number that comes before the b, meaning a, this is the a we know, here a is 1, it's greater than 0. Therefore, it means that the function is found where? Above the asymptote, guys. Hey, I hope this is understandable to us. So if they're saying here, write down the range of f, in our head we have a picture of a function where the asymptote we are told is y is equal to -9. But this function, since a is greater than 0, we are furthermore told that b is greater than 0. Now, we're kind of like at loss as to whether that b is greater than 0. Is it either going to give us a function that is increasing or decreasing? Because we are not given clarity as to that value of b. But what we do know is that the function can either be increasing above the asymptote or it can be decreasing above the asymptote. Either or, but the function is found above. So if it's found above, it means y is greater than -9. If we write the range of the function, y is greater than -9. So the range of f, y is greater than -9. Or we could say, why are we saying greater than -9? The asymptote, the horizontal line is y is equal to -9. So y is greater than -9. Or we could say y is an element -9 to who? To infinity, open bracket. That is the range for the exponential function. Okay, so the 3 marks, guys, I can get the 3 marks either by writing the range in this way, interval notation, or get the 3 marks by writing it this way, inequality form. Alright, hopefully that's clear. Any questions? No one? Anyone who wants to say something? Comment, query, concern, cry, anything? Okay, this is just a rough drawing. Okay, determine the value of b. Okay, now to determine the value of b, this is what we are going to do. Only Sinati, I don't understand how to get the range. You will soon. The function f of x is equal to 1. Here I say there is a invisible 1 that comes before the b. The b is to the power x, but before the b there is an invisible one that is there, not written down, but it's there. There's a 1 here. Also, b is what? Is there, we don't know what it is. X is an exponent, plus q. The horizontal asymptote is q, represented by q. We are told it passes point P, 2 and 0. So this is a point that lies on this function, and it's the x-intercept, and has the horizontal asymptote at y is equal to negative 9. So if we were to represent or sketch the function, there would be a horizontal asymptote, which is y is equal to negative 9. This is when the function does not touch, or does not cross, or does not get found, because this is the horizontal asymptote. It's y is equal to negative 9. So I'm saying, because a is equal to 1, this a that is, meaning a is greater than 0, that 1 of course, and we say that the function of the exponential, this one, is found above the asymptote. Guys, whenever this a value tells us something about the position of the function. If a is greater than 0, the function is found above the asymptote. If a was less than 0, if we had known that a is less than 0, the function would have been found below the asymptote. So when a is greater than 0, function is found above the asymptote. When a is less than 0, function is found below the asymptote. So we're going to imagine that maybe the function is like this above the asymptote, which would therefore mean that when we write down the range, what is the range? Range is the possible y values from bottom to top where the function exists. Range is the possible y values, okay, from the bottom to the top where the function exists. I repeat, range is the possible y values from the bottom to the top where the function exists. That is what range is, guys. So if you are looking at a exponential function found above the asymptote, because you know that a is equal to 1, okay, and a is positive, greater than 0, meaning the function is found above the asymptote. When you write the range, you say y is greater than negative 9. Y is greater than negative 9. The function is not found on this line, but it's found everywhere above this line. So we say y is greater than negative 9. Or we could say y is an element of negative 9, meaning from negative 9, but not on negative 9. That's why we have open brackets, from negative 9 to infinity. So from negative 9, from the bottom to the top, the function continues infinitely. So we say from negative 9 to infinity, open brackets. We don't include negative 9 because the function does not touch this line. We don't include infinity because infinity means it goes on forever, doesn't stop. Okay? So that is the range of the exponential function. That's how we explain range. Okay. So I don't know if only listener is still lost. If you're still lost about range, yeah. Stuff out here. Okay, b. Determine the value of b. Now, let's go and write the function. which function? F of x. So we say f of x is equal to b to the power x plus the q. Then because of what we learned, that the horizontal asymptote at y is equal to negative 9, it means we can say now f of x is equal to b of x plus negative 9. We substitute in the place of q positive times a negative, that will give us a negative 9. Okay, sorry, that looks like q, negative 9. Why do we put negative 9 in the place of q? It's because we were told that the horizontal asymptote at y is equal to negative 9. So in the place of q, we substitute negative 9. Then we can now go ahead and use this point, which is p2 and 0. It's a point that lies on the function. So we substitute 2 and 0. 2 is x. Okay, 2 is x. Sorry, let me just write that as x is an exponent. Sorry. 2 is x. This is x. 0, that's y. So we take the 0, which is y, we substitute it in the place of f of x. 0 is equal to b to the power 2 minus 9. Then here we are going to solve for what? For b. We have a difference of 2 squares. So when we factorize difference of 2 squares, we open 2 brackets. B plus 3 into b minus 3. Then we get 2b values. B plus 3 we can equate to 0. Therefore b is equal to negative 3. That's one of our answers. We take the other b minus 3, we equate it to 0. We solve for b, we get b is equal to 3. But now we have to decide which b value do we take. Because of this restriction, let's come down here. We were told here in the statement, furthermore, it is given that b is greater than 0 and b cannot be 1. So given this situation, which value can we accept? Can we accept b is equal to negative 3? Seeing as though we were told b is greater than 0, b cannot be 1, can we accept b is equal to negative 3? Can we accept b is equal to negative 3, guys? Or alternatively, can we accept b is equal to 3 rather? Which value of b can we accept? So b is equal to negative 3, we can't accept. So b cannot be equal to negative 3. So we always make sure that we say b cannot be equal to negative 3. Rather, b can be equal to 3. So therefore, guys, if we come back to the function, when we rewrite that function, okay, so we can conclude that b is equal to 3. If we write down, because the last question, 1.3 says that, so determine the value of b is equal to 3 alone. Okay, we find b is equal to 3. So we can write b is equal to 3. We found that out. Let me just review. How did I get b is equal to 3? Firstly, the function is f of x is equal to b to the power x plus 2. There, written. 2, we were told it has a horizontal asymptote of y is equal to negative 9. Guys, what is a horizontal asymptote? It is the untouchable line. The line where the function of the exponential is not defined. It is given by y is equal to negative 9. So in the place of this q, I substitute negative 9. Okay? Because y is equal to negative 9 is a horizontal asymptote. It is q, so in the place of q, I substitute negative 9. Furthermore, I'm told that the function passes through the point 2 and 0, p2 and 0. So there, I take the x value, take the point 2 and 0, substitute it, In the place of x, I substitute 2. Here is 2. In the place of y, I substitute 0. There is 0. Then I solve for b. And you can see this is 0 is equal to b squared minus 9. This b squared minus 9 is a difference of 2 squares from term 1. So I open 2 brackets. Square root of b squared, b. So I write b and b. Square root of 9, 3. I write 3 and 3. Sign positive and negative. Take b plus 3 equate to 0. B is equal to negative 3. Or take b minus 3 equate to 0. Take the negative 3 over, transpose it, b is equal to 3. Which b do I accept? This b. Why? Because I'm told b cannot be 1. B must be greater than 0. The only number between 3 and negative 3 that's greater than 0 is 3. So that's why I say the answer is b is equal to 3. Okay. I hope you understand. Okay. Umpilekat b, we are told here in the statement. Furthermore, it is given that b is greater than 0. So can we accept b is equal to negative 3 when we are told that b is greater than 0 in the statement? We can't accept b is equal to negative 3. We can only accept b is equal to 3 alone. So you must show this working out. Then conclude at the end, therefore b is equal to 3. Okay, hope that answers your question. Ompile kati. Okay, let's go on to 1.3. Hence, the word hence means use something that you have done in the previous question. The word hence, use something that you have done in the previous question to now answer the following question. Write down the equation of f in the form f of x is equal to. So we can write down the equation. Here is f of x. F of x equal b. We found the value of b. It's 3. 3 to the power x. Then the plus 2 minus 9. We found horizontal asymptote. It's minus 9. So the equation is 3 to the power x minus 9. We are happy. We are celebrating. All is very well. That is the equation. Okay, so far 3 marks for the range, 3 marks for finding the value of b, the correct one, according to the restriction. B greater than b cannot be 1. And then 1 mark for writing the equation of the exponential function correctly. So far, things are looking great. The last question says, sketch the graph of f on the grid provided in the diagram sheet. Clearly indicate 1, the what? The intercepts of the x's, 1, the asymptote in your sketch. So let's go and look for the diagram sheet. Okay, here is the diagram sheet. So I would then write my name in that diagram sheet. You know, Mr. Mac. Maths is a game. So that, yeah, I'm sure that of what I, my whatever. Then the next thing, since I'm asked now to sketch the function, remember the function is f of x is equal to 3 to the power x minus 9. Okay. All right, let's just be sure that it is minus 3 to the power x minus 9. Yeah, 3 to the power x minus 9. So firstly, based on the value of a being 1, it being greater than 0, we know that the function is going to be found above the asymptote. That we know. Function is going to be found above the asymptote. There's a 1 that comes, it's like there's a 1 times. You don't see that 1 times, right? But it's there, guys. It's the a value. B is 3. Okay, b is greater than 1. When that is the case, the function will be found above the asymptote and it will be an increasing function like this. You see? Okay. Then the x-intercept, we know, right? So guys, let's just say -9. Okay. Let's just extend this a little bit. Okay. Sorry. Extend this a little bit. Okay. Let's just say that is -9. We label the asymptote y is equal to -9. Okay, just label the asymptote. Secondly, from the function, our x-intercept, we are already told from the get-go 2 and 0 is the x-intercept. So we mark that as 2, all right? Then the y-intercept, let's just check what the y-intercept is by letting x be equal to 0. We don't have that yet. So let us let x be equal to 0. Then we say f of 0 is equal to 3 to the power 0 minus 9. 3 to the power 0, anything raised to the power 0 is 1. 1 minus 9. 1 minus 9 is -8. So f of 0 is equal to -8. Then x is 0. Y? -8. That's our y-intercept. When we let x be equal to 0, we find the y-intercept. -8 and 0. So let's just say, for argument's sake, that -8, we say it's here, and we mark that as the point. Okay, very rough, guys. Okay, 2, 4, 6, 8. You know, 2, 4, 6. Let's just do it like that. 2. Right, let's do that. I think that's better that way. 2, 4, 6, 8. We're counting in twos. Okay, just for the benefit of the sketch that has been provided. -2, -4, -6. Okay, we're counting in twos. 2, 4, 6. All right, are we together? So 2, 4, 6, 8 there. -8. So it's -2, -4, -6, because those are negative numbers. And what we do, we just sketch in here -9 for the horizontal asymptote, because horizontal asymptote is defined by the -9 there. Then we found our y-intercept by letting x be equal to 0 in the function. So in the place of x, we substitute 0. 3 to the power 0 is 1. 1 minus 9 is -8. That means y-intercept is here, -9. X-intercept is here, 2 and 0. We were told there from the beginning what the x-intercept is. If you go to the sketch, in the statement, look guys, let me show you. We were told that f of x passes through the point P, 2 and 0. That's the x-intercept. So that's why I say I know the x-intercept. I don't have to find it. So let's come here and draw our graph. Okay, sorry guys. This must be a nice smooth curve. So what we do is when we sketch this, okay, passing through the y-intercept, which is -8. Okay, I'm just gonna make that a little bit green so that it's distinct. And then 2 and 0, which is the point P, as has been explained. So that the x-intercept is visible, the y-intercept is visible, the horizontal asymptote is visible. One mark for the horizontal asymptote, you label it y is equal to -9. One mark for the y-intercept, very important. One mark for the x-intercept. And if there's a fourth mark, it will be for the shape. You can see the shape is a smooth curve. Arrow to show it goes on infinitely. Arrow to show that it approaches the asymptote but does not touch it. Any questions about sketching your exponential function? Guys, please, we gauge where the function is situated, the position, by the a value. When a is greater than 0, the function is found above the asymptote. If a is greater than 0, the function is found above the asymptote. But if this a value was a negative value, then the function would be found below the asymptote. Okay, you could even use your calculator to basically show you how the function develops, either whether it's increasing or decreasing. Okay, so please, guys, okay, I hope this is clear. If there's any questions, please ask. You know, I welcome your question. You can ask your question, I don't mind. Pagamile, what's the problem? You're requesting, what is your pain? Like, what's your pain?
Mania.
Okay, if you pagama and you come here, you pagamile, you stand up, and you keep quiet, I get.
Mania.
Pagamile, what's up, Mike?
I'm good, Mania. I've been losing contact on you, but now I'm back.
Okay.
Everything is coming so well. You can continue.
Okay. All right, so question 2 then, because we're done with the exponential function. We wrote down the range, we determined the value of b, we wrote down the equation of f in the form, and we sketched the graph of f on the provided grid in the diagram sheet, clearly indicating intercepts of the axis, the asymptote in the sketch. So it's good. Okay, now we go on to question 2. Question 2 is a combination of functions. Okay, so they're saying here, sketched below are the graphs of who? F of x minus 3 over x minus 2. Question, what type of function is this? F of x. Candyman is like, I'm too young. I wonder what year you're too young for, Candyman. Okay, so this is a hyperbola. Very good, Ompil. Hyperbola. Because the form is y is equal to a over x plus 2. So we know most hyperbola. The q value represents the horizontal asymptote. A tells us whether the function is situated either in your odd quadrants, when a is positive, first and third, or when a is negative, second and fourth. So you can see the a value here is negative, and you can see the quadrants where the function is situated. According to the vertical and horizontal asymptote, it's the second and fourth. So this is sketched correctly. Secondly, horizontal asymptote is negative 2. You can see that the horizontal asymptote is passing through the point negative 2. So even the horizontal asymptote, as the function is sketched, it's sketched correctly, because you can see a negative 3 when a is negative, second and fourth quadrant. Horizontal asymptote, negative 2 represents horizontal asymptote. There it is, it's passing through negative 2. So the horizontal asymptote is really y is equal to negative 2. Then we are told about g of x. What is g of x? G of x is equal to negative x minus 2. This is what type of function? Linear. Straight line, in other words. Okay. The gradient represented by the coefficient of x, which is negative 1. When the gradient is negative, our straight line decreases like that. As you can see, it's decreasing, so it resonates with the gradient. This here, for the straight line, represents the y-intercept, where the graph cuts the y-axis. There, the graph is cutting, you see, where y is negative 2. So this is true too. It's making too much sense. Now they are saying the graphs intersect where? At P, both of them, and where? And Q, both of them, respectively. And G intercept the y-axis. So G intercepts the y-axis at one of the asymptotes. It's saying at one of the asymptotes. Okay, but it's cut is actually intercepting the y-axis. Yeah, I guess if it's intercepting the y-axis is also an asymptote. It's a vertical asymptote, which is x is equal to 0. The y-axis is the line x is equal to 0. But it's saying at one of the asymptotes of f, which is this one, the horizontal one. Makes sense. Now, let's go and answer the questions. Please take note of something. There is a name for this function. This is something of this hyperbola. Okay, take note. So 2.1 says write down the following of f, the domain. 2.1.1, the domain of who? Of the hyperbola. What is the domain of the hyperbola, guys? What is the domain of the hyperbola? What is the domain of the hyperbola? What is the domain of the hyperbola? The domain of the hyperbola, x is an element of real numbers, but x cannot be 0. Vertical asymptote cannot be 0. The function of the hyperbola will never touch this y-axis, which has the equation x is equal to 0. So we say x is an element of R, that's half the answer. But x cannot be 0. You see, they've allocated 2 marks. So if you only write this is half the answer. The full answer is complete when you include and you write the restricted area, because the function is not defined here. Remember, domain possible x values where the function is defined. So it's defined everywhere, all right, but with the exception of the vertical asymptote, x cannot be 0. In the comment section, if you hear me, say yes, or you can say yes. If you don't hear me, say no. Thank you, Pagamila. You hear me, and you hear me. Who else hears me? Matlala, you are declaring Sitebe. You are saying no. Sitebe. When you need to go and find yourself a person, because thank you, Auntie, for the rose. As always, much appreciated. Thank you so much, guys. The domain. What is domain? Domain is what we say are the possible x values. Where do you find the function? Where is the function found from left to right? That's domain. From left to right, where is the function found? Well, look, you can see that the function of the hyperbola seems to be everywhere for x. It's continuing. You see this arrow is showing it's going on and on and on forever. It's continuing, but it gets limited by this line, this vertical line for x. What is the x value here? The x value is 0. The x value is 0. Is the function found on this vertical line? No. The function does not touch. This is called the vertical asymptote. The function doesn't touch this line. Okay? So therefore, we must restrict the function and say it cannot be equal there. Then you see here, it continues infinitely in that direction, everywhere for every other x value. So for all x values, the function is found except where x is 0. Sitebe, are you still lost? Sitebe, if you are still lost, my guy, then I'm sorry, I don't know. 2.1.2, the equation of the horizontal asymptote. In the comment section, guys, what is the equation of the horizontal asymptote? Let's see you guys type the answer for me. 3, 2, 1. Come on, let's go, guys. Let's go. Let's spam the answer. Spam the answer for the horizontal asymptote in the chat. Maybe you guys feel it when people use that sort of like flow, please, guys, when they say the equation, guys, an equation possesses a left-hand side and a right-hand side. When you fail to write a left-hand side and a right-hand side, then it's not an equation, it's something else. Okay, please, guys, don't be careless here. You see, Fiona, if you say -2, that's not an equation. You are just telling me a value, right? You are giving me a number. You are not giving me the equation of the horizontal asymptote. Please, guys, don't be careless here. You're gonna throw away marks unnecessarily, you people. Then you're gonna drive me crazy, and then you're gonna make me believe that I did not help you in this life. This year, y is equal to -2. Okay, thank you very much. Thank you, Fiona. Fiona, you are a spectre from the gods. Okay, especially because you listened very promptly and you gave the right answer. So you spammed right, guys. Very nice. Pagamila, I spammed wrong in the beginning. I don't know why. And then you yourself even wrote a number instead of writing the equation. You see, what nonsense. Washington, thank you so much. Very good. September, you're amazing. Unati Spenzi, when you just deserve all the best things in life. Fiona, very good. Tandoluhle, uyajwabaza uyabhatyaza Tandoluhle. You're not Tandoluhle ring when you are Tandolubi. Eh? How can you say y is equal to 2? Aibo, how did it? Guys, this here for the hyperbola, that value, -2, it defines what the equation of the asymptote, the horizontal asymptote, y is equal to -2. That is the value that gives us the horizontal. If they had said to you guys, what is the equation of the vertical asymptote, what would you have said? Can you spam the answer? That's right, that's spamsy. If they had said, what is the vertical asymptote, what would have you written as the answer? The equation of the vertical asymptote, what would we have said? Yeah. Pagamile, I'm gonna say you must sit down now. Thank you, Unati. Unati, you deserve all the things. Thank you so much, eh? I mean X. No, you're making, you're playing around with it. I mean, Fiona, very good. September, very sweet. Sweet. Guys, please, let's be clinical here. Okay, don't mess around. When you say now, if you're messing around, I'm gonna end the live. I'm gonna end it. I don't feel like I'm wasting my time here. 2.4. I'm gonna make you guys determine the following: the equation of the increasing axis of symmetry. The equation of the increasing axis of symmetry. What is the equation of the increasing axis of symmetry? When they say the increasing axis of symmetry, what do they mean? The increasing axis of symmetry. By the way, do we all recognize the fact that this equation of g of x here, what is it actually? This, guys, is actually the decreasing axis of symmetry. They didn't say it, but when you should be able to have the eyes to see that this here, g of x, is the decreasing axis of symmetry. Two things that show you that that is the decreasing axis of symmetry. I'll tell you what they are now. One, the axis of symmetry that is decreasing or has a negative gradient, firstly, has a gradient of -1. This has a gradient of -1 as a straight line. Two, the y-intercept of that straight line agrees with the horizontal asymptote of the hyperbola. Hey guys, listen to this. I'm saying two things. Why are we saying this is the decreasing axis of symmetry of x? One, the reason why we say so is because the gradient is -1. All axes of symmetries, grade 10, 11, and 12, for your hyperbola, if they are decreasing, if the axis of symmetry is a decreasing line or it has a negative gradient, it must have a negative gradient that is -1. Without fail, guys. It can never be any other. It's -1. Full stop. Okay? And g of x happens to be -x. Are you with me? Because there's a coefficient of -1. Two, the y-intercept of that axis of symmetry must agree with the horizontal horizontal asymptote of the hyperbola. So you are expecting to have the same value here and there. That is why I know if they had probably asked, sorry, it's minus 2. So if they had probably asked us to share what is the name of this g of x in the hyperbola, we would have said this is the decreasing, or we could say this is the negative gradient axis of symmetry. So if the negative gradient axis of symmetry is like this, what is the positive gradient axis of symmetry? We know that the positive gradient axis of symmetry should have a positive 1 as a gradient. That's the first thing. So the number that is before x is 1, positive 1. You can DM me Razo if you want. Positive 1 is the coefficient. Okay? Then the horizontal asymptote of the hyperbola is going to be the value of the y-intercept. So the positive gradient axis of symmetry, or the equation of the increasing axis of symmetry, is actually going to be what? Y. So now I'm answering now. Why is it, what is it going to be? Tandoluhle, you answered very well. You see, Tandoluhle, you answered very well. Now you are talking, Tandoluhle. You are Tandoluhle for sure. None of this nonsense now. You are really following. You know, Tandolubi here. Tandoluhle. The positive, the increasing. Guys, the word positive gradient x of symmetry or increasing x of symmetry, the other word that they use instead of increasing, they say positive gradient axis of symmetry. It's the same thing as increasing axis of symmetry. All right. So the increasing axis of symmetry is x minus 2. Y is equal to x minus 2. The increasing axis of symmetry is y is equal to x minus 2. So uthando luhle is Thando Luhle ring. Very well. And I'm very proud. Thando Luhle, round of applause to you. Guys, I hope, guys, you don't have to do much when you write the axis of symmetry. If you know that if you are told it's the increasing axis of symmetry, then you know the gradient is 1. Always positive 1, guys. It will never be any other positive number. It's always positive 1. So you know for sure gradient is positive 1. If it is the decreasing axis of symmetry, then you know that the gradient is what? Negative 1. It can never be any other negative gradient. Then, for the constant value, that constant value always agrees. The y-intercept of the straight line, which is the axis of symmetry, agrees with the q value of the hyperbola, the horizontal asymptote. They will be the same value. Okay. Why will they be the same value? Maybe you're wondering, why are they going to be the same value? Look, guys, look at this. Look at this horizontal asymptote. It's y is equal to negative 2. Look at where the axis of symmetry cuts through. It cuts through the same line, which is the horizontal asymptote, which is negative 2. That is why our y-intercept agrees with the q value of the horizontal asymptote. So you can simply write the equation. That is why we simply write the equation of the increasing axis of symmetry as what? Y is equal to x minus 2. Finished. Gradient, positive 1. Invisible, unseen. Y-intercept agrees with the horizontal asymptote of the hyperbola, which is, in this case, negative 2. So therefore, that's why we put negative 2 as the value there. Okay, then the next question, which is 2.2.2, says the x-coordinates of P and Q. What is P and Q? Let's first start there. What is P and Q? Here is P, there is Q. What is P and Q? What do we call P and Q, guys? Someone answer me very fast. What is P and Q? We call those points the points of... these people are wasting, not telling me, no one's telling me nothing. I have to give you everything, guys. Thank you, Statham. It's the point of intersection. Thank you. Intersection. Okay, so 2 marks there. We would give 2 marks for the equation of the increasing axis of symmetry. Remember, guys, the alternative wording that they usually use when they want the increasing axis, they can say the positive gradient axis of symmetry. Okay, so there are cases sometimes where they want the positive. If they say the decreasing axis of symmetry, then you know they want the one that has a negative gradient. Okay, or they can say the negative gradient axis of symmetry. Okay, but sometimes they want both. They'll just say to you, write down determine the equations of the axes of symmetry. Then you know they want both of your axes of symmetry, so you need to just write them both down. Okay. So point of intersection, P and Q. So that means what? You take f of x, you take g of x, you equate them. It's as simple as that. You take f of x, you equate it to g of x. And here they specifically said they want only the x coordinates. So f of x, let's check f of x. What's f of x again? F of x is -3. G of x, f of x is -3 over x minus 2 equal to what's g of x? G of x is -x minus 2. G of x is -x minus 2. When we transpose the negative, it becomes plus. Negative plus 2 gives us 0. That leaves us with -3x is equal to -x. Then after that, what happens? We cross multiply. -3 is equal to -x squared. And after that, what happens? Divide both sides by -1. We get 3 is equal to x squared. Then some people can decide, take the square root on both sides. When you do so, do not forget to put plus minus. Then after doing so, you say x is equal to plus minus the square root of 3. So guys, that in essence means x can be equal to √3 or x is equal to -√3. And we end here. Why? Because the question says, or they say, determine the x coordinates only of P and Q. So that means, let's specify. If we look at P where it is, it's on the negative side of the x value. If we look at Q where it is, it's on the positive side of the x value. So let's be specific and say the x of P is √3, the x of Q is -√3. Actually, sorry, it should be the other way around. The x of P should be negative, and the x of Q should be √3. Okay, are we following, guys? Let me just go back and repeat this. Since P and Q are points of intersection, we take f of x and we equate it to g of x. As simple and straightforward as that. Then after doing so, what do? We solve for x. Okay, we take the -2 over, -2 plus 2 becomes 0. We are left with -3 over x equal to -x. We cross multiply the x, we get -x squared is equal to -3. Then because here we've got a negative and a negative, we divide both sides by a negative to get x squared is equal to 3. We then take the square root of x squared. Take the square root of 3 on the other side. But when we take the square root on the numerical value, we put plus minus to show that there are 2 possible answers. So x is equal to plus minus √3. that means two answers. Either x is equal to root 3 or x is equal to negative root 3. But then, of course, the q is on the side of the negative. Sorry, the q is on the side of the positive. So we say x of 2 is root 3, and then the p is on the negative side. So we say x of p is negative root 3. Okay. Any questions yet? All right, I think we are done with hyperbola and exponential as far as the questions in this question paper are concerned. And we can safely say that full marks is ours so far for every single question that we have been able to answer. Okay, every single question. The 4 marks here at the end, they are yours. Great. Then you equated the functions, right? And then got the values of x. Okay, very nicely. Okay, using algebra and solving of equations. Let's not forget, guys, f of x is equal to g of x. Transpose the negative 2, you get negative 2 plus 2, which is 0. You are left with negative 3 over x on the left is equal to negative x on the right. You then cross multiply the x, you get negative 3 is equal to negative x squared. You then divide by negative both sides so that it's left, you are left with 3 and x squared. You take the square root to get rid of the square. But what you do on the one side, you do on the other, but don't forget plus minus for the numerical value. That means there are two possible answers. So x of 1 letter, which is root 3, because x is on the positive side, q is on the positive side, point p is on the negative side. Those are your final answers. Let's go down and move on to trig functions. Okay, drawn below are the graphs of f of x. How beautiful. Is equal to tan x f of x, and then g of x is equal to a sine x plus 2, for x is an element of 0 to 360. You can see that these are nice functions of tan and sine sketched on the same system of axes. The tan graph is the mother tan graph because its f of x is equal to 1 tan x. It's the mother graph. And we know the development of the mother graph. What happens? Okay, obviously it increases from 0 to 90. Then it does the same from 92 to 70, experiencing a period of 180 degrees because this is a full cycle of the tan graph. Okay, tan has a period of 180 in grade 10. Okay, and it's 180 for all tan functions. Then from 270 to 360, okay, you can see that arm there. Okay, sorted. Ne? And the other function is a sine x plus 2. We don't have the value of a, we don't have the value of q. So it's going to be our responsibility at some point to find the value of a and q. Lastly, we are told that the functions are sketched within the interval of 0 to 360. 0 is included, 360 is included. So you're expecting to find the function on the y-axis, you're expecting to find the function reaching 360 degrees. Okay, now let's go and answer the questions. For the given domain, write down the following using the drawn graphs. 3.1.1, the period of f. Who is f? F is the tan graph. What is the period of f? Can you spam the answer in the comment chat? Okay, Pagamile says 180. What does the rest of the crew say? The period of f. The period of f. 0811 is saying 180 as well. 0811. I see you are a level 9 gifter here. Welcome to the live. Are you in grade 10 perchance? Or are you in grade 9? Since you are a level 9 gifter as well. Or are you possibly in grade 12? Okay, so 2 people have said 180. You're in grade 12. Okay, this is basically grade 10 maths, by the way. All right, when are you writing your paper for trial, Michael? And are you doing really well? We're getting level 7, distinction end of the year, distinction trial exams. Period of f, guys. Okay, the tan graph, as you see it, Okay, 180. Thank you. Very good, guys. All those who said 180, beautiful. Is that when you're writing paper one, my dear? Is that when you're writing paper one, Maths? Or is that when you're writing paper two on the 4th? Okay, you guys should go follow me on my other channel. Maths is a game. That's where I do grade 11 and 12 oriented work. So I'm gonna try and utilize some of my evening times to basically also tend to grade 12 on my other Maths is a game TikTok channel. Anyways, period is 180 degrees, guys. Very good. 3.1.2. What is the range of G? What is the range of G? What is the range? Hold your horses, my guy. We are coming there. Hold your horses. Hold your horses. Finding A, just hold your horses. We're gonna get there. What is the range of G? G is the sine graph. Here it is. Okay, this is the full cycle of the sine graph. Okay, starts at 1, ends at the very same height of 1. So that's a full cycle. Someone tell me what the range of G is. Range is the possible y values where the function exists from the bottom to the top. Started from the bottom, now we're here. Started from the bottom, now we're here. That's what you should think about when you start think about the range. Started from the bottom, now we're here. Okay, you can't say started from the top, now we're here. No. You started from the bottom, now we're here. So as you start from the bottom, what are you covering? Hi, Suga. Ompile kaji shy to answer my foot. I'm gonna smack you across the face. Pagamile. Pagamile. Something is seriously wrong with Pagamile. Pagamile is answering nonsense in the comment section. Pagamile. And when you know better. That's why I'm actually really like I'll smack you across. You'll smack you when you need a smack. Have you seen the boy that was a corporal punished by a principal in another school? I think Pagamile deserves that right now. DJ, what's happening? Okay, right. Zwite Kalanga, very good. Zwite Kalanga is answering 100%. Zwite Kalanga's answer is the one that is 100% correct. Zwite Kalanga. Guys, the 1, 2, 3. We include 1, we include 3. So we say y is an element, square bracket, -1. We include 2, 3. We include. We don't exclude. It's not open bracket, it's square. My goodness. My. Brackets and all. Okay. Alternatively, others may decide to use inequality form, meaning y is greater than or equal to -1, but less than or equal to 3. This is an alternative way of writing the same range. 2 marks if you write it this way as well. Those who used open brackets, 1 mark gone. Why? Because you used the wrong brackets. Values are correct, but brackets are wrong. Remember, guys, when where it begins, if it touches where it begins, then you include square. If it touches where it basically reaches at the top, you include square bracket, please. Otherwise, you are going to sabotage yourselves. You're going to lose marks, you guys. You don't care about it. You guys don't want high marks, ne? You like these mediocre marks. You like getting marks that are swag. Guys, me, I want excellence, man. Value of Q. The value of Q. Okay, the value of Q. I want to tell you something, credence. You must note this thing. The Q value here, all right, when you have the sine and the tan graph, the Q value is the y-intercept, just for them only in grade 10. Okay, that's a clue for you guys. The Q value is where the graph cuts the y-axis. So if you know, if from your sketch you can see where the graph is cutting the y-axis, where is the graph cutting the y-axis? For sine only and tan, not cos, guys, just for sine and tan, your q value is always where the graph cuts the y-axis. I repeat, guys, this is only applicable to sine and tan in grade 10. I'm giving you teaspoon tips here. Grade call you what you want, grade 10. Okay, I am saying to you, the q value here is the y-intercept, where the graph cuts the y-axis for the graph of sine and tan in grade 10. I'm giving you teaspoon tips here, but this is not relevant for cos. Cos is not this. It's not like that. Only for who? Only for who? Only for who, guys? Q is the y-intercept only for which two functions? Spam W in the chat, guys. For only which two functions is Q the y-intercept? Which two functions? Hey, these people, they're just for sine and tan. Thank you, Ompilekat. Not for cos. Don't ever do it for cos, guys. It's only for sine and tan. It's a clue. It's a trick. You know? If just for sine and tan, in grade 10, not for cos. For cos, it's a different story. Please take note of that. So for me, it's easy to say what the value of q is. I go and look, where is the function cutting? The function of who? The function of g. Where is g cutting the y-axis? It's cutting it at 1. So that therefore means q is equal to 1. Alternatively, you could work it out. All right? You could work it out. And the way you work it out, guys, is that you can say q is equal to max plus mean. You divide it by 2. Max plus mean, not max minus mean, but max plus mean to get q. I'm talking about this q. Now that one, this formula you can apply to the cos and the sine graph alone, not to tan, because tan doesn't have a maximum and a minimum. Are you with me, guys? So you can use this to determine q, max plus mean divided by 2. Only for cos and for sine you can use this formula. The maximum for the sine graph, what is it? It's 3. The minimum, the minimum is negative 1. So it's 3 plus minus 1. What's 3 minus 1 divided by 2? It's 2 over 2, which is equal to 1. So you see the q value. Okay, if you use the formula. So it's up to you what you want to do. I said to you, for sine and tan, the q value is always the y-intercept. For sine and tan, for sine and tan, for sine and tan, the q value is always the y-intercept. For sine and tan, for sine and tan, the q value is always the y-intercept. Okay. I hope you guys get it. Okay. That is grade 10. Because I'm doing a grade 10 paper here. Okay. Now, some of you now are asking about the A. How would you determine the A value? Guys, the A value, you first look at the shape of the function. Okay. Mothers are the most positive people in the world. They should be. Your mother should be your greatest supporter. She should be the one that believes, the best out for you and about you when you don't believe the best about you at all. Ideally, ideally, in the ideal world. But, so this function here is like the shape of the mother. Mother's sign is shaped like this from the It starts off increasing, decreases, increases. That's how mother is. Okay, the parent, yes, the mother graph. So mothers are very positive. In other words, the A value will be positive as long as it resonates with the mother graph. So we can use what we call the formula for amplitude to calculate or to help us calculate the value of A. So we say amplitude is equal to max minus mean divided by 2. Not max plus mean, but max minus mean. This is just the distance from the position of rest to the highest place. All right. Yeah. So that is the amplitude. It's the distance between the position of rest to the maximum. So we say max minus minimum. What is the maximum? It's 3 minus, what is the minimum? Negative 1 divided by 2. So 3 minus minus 1 is 3 plus 1 divided by 2, which is 4 divided by 2. What's 4 divided by 2? It is 2. So this is the amplitude. It's not the value of A. We confirm it being the value of A by looking at the shape of the graph to judge whether we should say that A is positive or negative. We judge whether A is positive or negative by looking at the shape. If the shape of the function resembles the mother sine graph, then of course we say A is positive too. But guys, if this shape of the sine graph did not resemble the shape of the mother graph, it was starting off decreasing, then increasing, then decreasing, then we would have said A is negative. So that's why I was saying to you, the most positive people in the world are our mothers, the parent. They should be. Likewise, the value of the amplitude will be for A positive if the shape resembles the mother. But if it does not resemble the mother, we would have said that the value of A is negative too. Okay? Please, guys, please check if the shape of the function given to you, does it resemble the mother graph? Okay? That's if you decide to use this formula. Okay? If you use this formula, okay, you would do that. Okay? Please, guys. All right? Yes, Zwite Kalanga, you've explained very well in the comment section. Good for you. Right? Good for you. So 1, 2, using the formula of the amplitude and then getting the value of A. If they had asked us for the value of A, we would have said A is equal to 2. Straightforward. Positive 2 foot. Okay? Now let's move on. They are asking the number of solutions of f of x minus g of x is equal to 0. Okay? The difference, where the difference of these two functions gives us 0. Or you could look at it another way and keep f of x on the left, take g of x on the other side, make it equal to g of x. Then what are we looking for? We are looking for where the two functions intersect. Tina, we want to know how many intersections do we have? That's all. So we go to the functions. From 0 to 360 in the given interval, how many intersections do we have? 1, 2, at least the ones that are visible. So we go here and we say the number of solutions, 2 solutions. They didn't say what are the values of x. They just said the number of solutions. Okay, we must always read the question, guys, and answer what is asked. We don't answer what we want. We answer what is asked so we can get the marks we want. We answer what is asked so that we can get the marks we want. We don't answer what we want. Okay, are we together, guys? What is the Lord with us doing here? The Lord with us at night? Okay, the Lord with us is not answering. So that means the Lord is absent, not with us.
Sir.
Yeah, the Lord is with us. What's happening, my guy?
I'm good, sir.
You just request for the sake of requesting.
Oh, I'm studying.
Oh, you're studying. No, I continue studying, my guy. No problem. Okay. So hopefully 3.1.4 is fine. We are good. The number of solutions of f of x minus g of x is equal to 0. Same thing as saying the number of solutions f of x is equal to g of x, which means points of intersection. So we check how many do we have? 1, 2. Claro. Because they said the number of solutions. That's all they want. Number of solutions. They didn't say give us the x value. They say the number of solutions. So we have 2. Claro. Claro. Let's continue, guys. Let's continue. 3.2.1. So we're getting these marks are ours. We are getting them. You know, 2 was 1. We got that mark. 180 degrees. We got that mark. Range. We got that mark. Okay. Yeah. But for this condition, Galok, my guy, you are asking me. So the number of solutions are always the point of intersection for this solution. For that solution, yes. For that solution, it is. Okay, the number of solutions of f of x minus g of x. So what I did to make life easy for me so that I can know what we are to, I took the negative g of x, I transposed it. This means f of x is equal to g of x. Are we together? The two functions are equal. So then I check, what is f of x equal to g of x mean? It means where the two functions intersect, where the two functions meet. All right, where f and g are meeting there, f and g are meeting also there. So we count how many are those, that and that. That's two solutions. There's nowhere else where we can say f of x is equal to g of x apart from those parts. Let's go on. 3.2. Time is not against us. You see, we are after 12 now. We can't sleep at 1, guys. You must sleep before 1. You must be done with this paper. Use the graphs to write the values of x in the given domain for which g is decreasing. Use the graphs to write the values of x in the given use the graphs to write the values of x in the given domain for which g. So we are focusing on g. We want to check where is g decreasing. Which values of x show the function of g decreasing? Where is g? Okay, so I'm going to use blue to show where it's decreasing, green where it's increasing. So here it's increasing. Okay, from 0 to 90, it is increasing. Then here, from that point, it turns. I'm going to use blue. This is decreasing, going down. Okay, that is from 90 to 270. We are decreasing. So my first answer, 90 to 270, we are decreasing. So I'm just going to use open brackets because I can choose to include that turning point or not. Either way, it doesn't matter. If I include it, I'm going to be marked correctly. If I don't include it, I'm still going to be marked correctly. Here, it's increasing again. So what did they ask me? They said, use the graphs to write the values of x in the given domain for which g is decreasing. So the function is decreasing between 90 and 270. I'm not going to include 90. For myself, I'm not going to include 270. But you know what, guys? You will not get penalized if you decide to include both of those values, because there is still not a consensus amongst mathematicians as to whether we mark wrong or right if we include or not include. There's still an argument. It's ongoing. It's never ending. You can sit, like, you can go ask your teacher. Another teacher will tell you this. Another teacher will tell you this. But what is very, very comforting is that whether you include or don't include, you will get the marks for questions related to decreasing and increasing, because mathematicians are still arguing as to whether do we include where we turn or don't we. Okay, so when you can choose what you want. Mina, I can say x is an element, open bracket, 90 to 270. That is where g is decreasing. How many marks? 1, 2. interval, or if I choose to write my answer in inequality form, I can say, what can I say if I write my answer in inequality form? Can the answer be written in inequality form? Yeah. Yeah. But even if, guys, I wrote this, I would still be marked correctly. Okay. The memo should basically include all the possible options. So that would be 2 marks whether I write it like this or like that, or write 2 marks for that or that. It doesn't matter. Okay. Yeah, because of that consensus that has not yet been attained. Then 3.2.2 says, use the graphs to write the values of x in the given domain for which f is undefined. In the given domain, guys, where is f undefined? Well, there are 2 places where f is undefined. F is the hyperbola. Sorry, not the hyperbola. It is the tan graph. At 90, very good. Zwide kalanga. Yeah, zwide kalanga. Hayi wena uyavuta, my guy. You are votering. You are burning. Okay? Yes. X is equal to 90 degrees and x is equal to 270 degrees. So you can literally just write those two together. Okay. Yeah. X is equal to 90. X is equal to 270. That's all, guys. That's where f, meaning the tan graph, is not defined. It's not defined on the vertical asymptote. X is equal to 90 and x is equal to 270. Why? Please explain. What do you want me to explain now? The one. What do you want me to explain, my guy? Explain what? F is undefined. Where the function does not exist. That's where f is undefined. Where the function does not exist, it's on the asymptote. It doesn't exist, the function on the asymptote. The function increases, approaches, does not touch this line. The function does not touch this line, even here. It does not touch this line, even there. This is called the vertical asymptote. X is equal to 90 and x is equal to 270. That's where the function is not defined. That's where the function does not accommodate itself. You know, it's a boundary line. It's an untouchable line. Asymptotally function, asymptote, asymptotally function. Yes, the one.
I see now. Say,
yeah, akatholakala function laphaya.
The points on the graph cannot be read.
Sorry. Yeah, you can't read. Yeah, you can't read. Yeah, they can't be read here. Yes. The function is not defined. Maths error. You know, these people, they cry, maths error. What is tan of 90? Maths error. It's not defined. The function not defined there.
Yes, sir.
Yeah. Okay, thank you very much. Let me continue now. 3.2.3 says, use the graph to determine the values of x where g of x is equal to 1. Where's g? G of x mostly is there. It is the sine graph. G of x is equal to 1 here.
Where x is equal to 0.
So y value is 1. Where x is equal to what? 0. Amen. Okay, that's one place where that is the case. Also, where else? Here. Where x is equal to what? 36. That is a distinct defined place where we know for a fact. All right. But is there anywhere else where that is possibly the case? Here.
1.8.
You see? Yeah.
Yeah.
So there's 3 places. So I say where x is equal to 0 degrees, or x is equal to 180, or x is equal to 360. 3 beautiful answers there for 3 marks. 1, 2, 3. Even the undefined 1, 2. You see? High marks galore, my guy. Yo, full marks. 100%. We are smiling. You're smiling. The test is just being, you're massacring it. You are taking it to, you see, all the marks are yours. Okay, trig functions. Exponential functions. Functions. Anything that says functions. We don't feel it. It's not feelable. It's not feelable. Now, guys, in these questions, there are questions that were not asked. Like, there are other questions, like the f of x times g of x greater than 0. F of x greater than or equal to g of x. There are other interpretation type questions that were not even featured here in this question paper. This question paper is limited to the questions that were asked on this particular question paper. So those are blind spots for this question paper. That does not mean just because I'm doing these questions, when I should be like, oh, those are the only questions I should know. No, my guy. You need to make sure that all other questions related to functions, when you can be able to answer. Okay, so I proceed forward because obviously I need to finish this guy. Hey, I need to finish, guys. Hey, I can't be here at 1 o'clock, 1 p.m., 1 a.m. Need to go. Question 4. Airplane stuff. 2D. An airplane at point D here is flying directly over point A. Here is point A. The airplane is flying directly over point A on the ground at a height of 5 kilometers. There is the 5 kilometers. These things that are mentioned in the statement, they are reflected in the diagram, which is what we want. If there's any piece of information that we read here, it's not reflected, we are going to fill it in, so we update our diagram. It is heading to land at Zamdala Regional Airport, which is point C. Yes, the plane is going to land. You see, most when the plane is about to land, it basically takes a particular displacement towards its landing place. Very key. Right? Does not continue to fly in that horizontal sort of like plane, if you want to call it that. It descends, to its landing place, the airport. The angle of depression, A, depression, from point D here to point C there is 8 degrees. Makes sense? Because what do we call the angle of depression? We say it is the angle formed by the horizontal line and the line of sight as the plane is taking its sight looking to the airport. This is where the pilot is basically looking. It's the line of sight and the horizontal. The angle formed at the top looking down. When you are depressed, you are high up in the mountaintop, but you become down, very down. So the angle of depression, the angle from the top looking down, that is basically depression. The angle there is 8 degrees. Are we together? Point B is along the route from A to C. Point B is along the route, as you can see, from A to C. Point B is there. Now, they are saying in question 4.1, write down the size of angle DCA. When they give the name of the angle in this way, we must know that the middle letter denotes the angle, because there's a caret. That little cap is called a caret. It distinguishes that sign as a letter. So they say write down the angle of DCA. What is it? DCA. In other words, this angle. What is it? I see you there. Angle DCA is equal to 8. Let's spam in the spam there in the chat, guys, the answer of the angle DCA. Zwite Galanga is saying, sorry, don't say, just be specific to what they said. DCA is equal to, don't say C. Please, guys, be specific to what they said. I will try and upload it to my YouTube channel when I'm done. Yeah, I'll try ASAP. Angle DCA is equal to, yes, you guys are correct. It's 8 degrees. Why? Of course, no reason is needed to be provided because we are dealing with the geometry of it's trigonometry, it's not Euclidean. But if you do provide a reason, it makes even your statement that much more powerful. So yes, alternate. You can see Z shape, N shape. Yeah, it's alternate because your horizontal arrow direction parallel state, therefore alternate angles. So you are right, 8 degrees. We fill in the info that we find after finding it. 1 mark is in the back. Next question. Calculate the distance AC. AC is to the nearest kilometer. So my calculator people will be on standby. But when we are answering such questions, there are questions we ask ourselves. 1, AC, where is he? AC is here. In which triangle do we find AC? Then you tell me the triangles where you find AC. Triangle DAC. What type of triangle is triangle DAC? It is because of this box here, right-angled triangle. Which trig ratio can we use to find the side AC? So I can see in the comment section, people are saying tan. The one says we use tan. Vamesa Jericho is even going on and saying tan 8 is equal to 5 over AC. Beautiful, Vamesa Jericho. We use tan, guys. So when we use tan, we look at what we have. 5 we have, and 8 we have. We have an angle and a side. This given angle with the given side. What is the relationship? The angle gives us a opposite, and the angle helps us to find the adjacent. So we have opposite and adjacent. Then what trig ratio fits the description? As the Professor Jericho said, tan. Let's go straight to the point, guys. We know we are working with triangle DAC. So we say tan 8 degrees is equal to 5 kilometers over AC. And guys, we don't waste time and do long things. When the unknown is in the denominator in our fraction, what we need to calculate, we interchange. AC replaces tan 8 replaces AC, because tan 8 on the right is in the numerator. AC on the left, tan 8 on the left is on the numerator. AC on the right is in the denominator. So you can interchange. So we can say AC is equal to 5 kilometers over tan 8. Let's not waste time, guys, and do long things that are unnecessary. Time is of the essence. Then you take your calculator. You tell me what's 5 divided by tan 8 so that I can smile because of you. Give me the answer rounded off to the nearest kilometer. Okay, nearest kilometer, not rounded off to, because you see they specify in the question that we need to round off to the nearest kilometer. Okay, so we must be careful there. Nearest kilometer. Nearest kilometer. Okay, so what is the nearest kilometer? What would be the answer if they are saying nearest kilometer? Nearest kilometer. No problem from message. That's why I'm here, because when you are writing the test at school, you must have your eyes wide open. You must have your mind wide open. You must have your awareness on high level so that you do not miss nothing. Okay, so the final answer for AC is going to be 36 kilometers, guys. No playing around, because we've rounded off to what? the nearest kilometers. Comma 5 after 35 means we round up to 36. Okay? Right. Please, guys, don't waste time. Interchange. If the unknown is in the denominator, interchange. If the unknown is in the numerator, cross multiply. That's how we isolate the unknown so that we can make it the subject of the formula. I repeat, if the unknown for your trig ratio is in the denominator on the other side, you do what? You interchange. If the unknown is in the numerator for your trig ratio, you cross multiply. So we cross multiply when the unknown is in the numerator. We interchange when the unknown is in the denominator. These are shortcuts, guys, that make life easy. We get straight to the point. We don't waste time. We move on to the next thing. Are we together? Don't want to be wasting time doing long things that will complicate life. Let's get straight to the point. Okay, so that's our answer. And the marks are ours. 3 marks, trig ratio, interchanging, the beautiful answer rounded off to the decimal place or to the nearest as they've asked it. 3 marks in the bag. We are smiling. You're smiling very wide. It's a very good day. You see, it's the sky. Yeah, that's what happened. Move on to 4.2.2. We update info 36 kilometers. We move on next. That's ABC. We know distance AB. Where's AB? Distance AB. They want this distance. This one. This one. If BC is what? If BC is what? 8. So here we know the full length is 36. We've just worked it out now. Full length of AC is 36. Full is 36. Then we are now told BC is 8. This part. Then they want us to find what? AB, the other part. So if we have a whole, which is 36, and a part, which is 8, how do we find the other part? Okay, it's very simple, most. We want AB. So we say AC minus, very good, AC minus BC. So AC, 36 kilometers. BC, minus 8 kilometers. Final answer, 28 kilometers. So let's show this, guys. Okay, because they say calculate. Calculate is a verb, which means I need to show, you need to see. We need to see what you are doing. We don't just want answers to be written. We want you to show, because it says calculate step by step. So that's very important. So, you know, that's where you just showcase your prowess, you know, you showcase your stuff. Okay, and then once we get something, we update Mr. Diagram. 28 kilometers is in there. Okay, makes sense. Right. 4.2.3 says the angle of elevation from point B to D. Point B to D. We want the angle of what? Elevation. Angle of elevation from the bottom looking up. So we want this angle, Shem. Okay, from the bottom looking up. Elevate is to lift up. You don't lift up something unless it was down somewhere. So the angle is at the bottom. So this is the line of sight and then the horizontal. There's an angle formed. We call that angle the angle of elevation. What does it mean to elevate? It means to lift up. I'm hoping you guys will elevate your marks for the tests that you are writing, because I am here helping you this beautiful after 12 what is it, 22 minutes to 1 a.m.s. My guys, James. So angle of elevation. So we ask ourselves, where is this angle? You see, once again, just like when we asked AC, where is AC? Where is the angle? The angle is found in triangle DAB. Now, what is there? You have an angle theta, which you don't know, which you want to find. You have the side 5 kilometers. What is it in relation to this angle? It is the opposite. You have another side in that triangle AB, which is 28. What is it? It is the adjacent. What trig ratio uses the opposite and the adjacent? We know the trig ratio is? Yes, you said it. Yes, Zidegalanga. Thank you, Zidegalanga. The sun is coming out, as we eat. These people with their names, where in the world do you guys come up with such names? What the freaking guys? Where in the world do you guys get these names? Informer is a Jericho, Zidikalonga, the one. Like, you guys. Okay, tan theta is equal to 5 kilometers over 28 kilometers. 1 mark for setup of the equation. Now, we know, all right? So that tan of theta, okay? So we are just going to let that angle DBA be equal to theta, all right? I think that's very important because people are going to be like, but where does the theta come from? Okay? Just letting angle DBA, the angle of elevation, be theta, okay? Yeah, I think it's important to notify. Unless you can just say tan of angle DBA. I mean, then that makes life even easy. Tan of angle DBA. We must be specific, guys, in saying angle DBA or saying angle ABD. We can't say this is angle B just like that. Unless we specify first in triangle DAB, then we can say angle B. We can use one letter if we specify at the top in triangle DAB. Then people are going to be like, okay, this person is talking about triangle DAB. Then they see tan angle B. They know you are talking about the triangle DAB. But just to be safe, I would just say use the 3 letters angle DBA or angle ABD with the caret on top of the letter of the angle. Anyways, so I let angle DBA be theta, meaning that is my angle of elevation. Now I can solve. Let's go and solve. 5 kilometers divided by 28. So we isolate the angle. We take the inverse. Let's not forget, guys, these things from when we were doing trigonometric equations, because now it may have been a time and we've forgotten. Okay, when we are working out an angle, we take the inverse of tan, or we say arctan on the right hand side. Then we'd use our calculator. Now I'm relying on you because I don't have my calculator here deliberately so that you guys can punch it in for me. They didn't specify to round it off anywhere, so we revert back to the instruction in the front cover under instructions and information, which says round off all answers to 2 decimal places, so if necessary. So what is the answer, guys? And this is an angle measured in degrees, so I must have the angle in degrees. Okay, so what is the arc of tan? 5 over 28. Okay, we're not rounding off to the nearest degree. Here we are going to round off to 2 decimal places. Please, guys, is it 10 on the dot? Hey, you guys are making me lantuka. Is it 10 degrees? Let's be careful, guys. We were coming from rounding off to the nearest kilometers. We followed the instruction as it was said. We don't do that if there is no specific instruction in the question. In the question, there's nothing said. So that means we go to the instruction, answers, if necessary, round off answers to 2 decimal places unless stated otherwise. So now we round off to 2 decimal places. We have no choice. If you say 10 degrees, you'll be penalized. So the answer is, okay, I see majority saying 10, 12 degrees. Thank you. right? Hopefully the rounding off is 100% spot on. Okay, how many marks there? 2. Okay, please, man. There. Okay. Full marks there. No marks lost. Everything that we need is ours. Yeah, it's ours. Yeah, it's ours. Okay. Goodbye. Triangles 2D. Hello statistics. Okay. Hello statistics. So first we're dealing with ungrouped data, and then obviously the next one is grouped data. So there's ungrouped and grouped, and then that's the end of the paper. Statistics is the end for this particular paper. Okay, so yeah guys, here's the question. The data below is the mass in kilograms of how many athletes? 10 from Metzima Holo Olympics team at Oraniaville. Orania. Okay, the mass, how much they weigh, these athletes. So let's look at the weight. We're 50 and it's in kilograms, right? 50, 55, 89, 63, 64, 79, 72, 72, 55, 78. The question that is first asked is write down the median of the data. So I'm sure this is, I mean guys, statistics is maths lit, ne? So this is very light work. Nice, romantic. It's like candlelight dinner. You know, open a bottle of, like, what is it? No, we don't do shambombo here. We do a bottle of Oros, you know, with some biscuits. I don't know, like, yeah, just nice times. We enjoy, we answer the questions, we get full marks. Everything is ours to chow here. Okay, it's like chow town. So when you say write down the median, what is the median, Kanen, by definition? Because the median is the middle number, ne? Yeah, it's the middle number of our data set when it has been arranged in ascending order. You must first arrange the data set in ascending order. You cannot identify the middle number unless the values are first arranged. So we do that first. We arrange the numbers from smallest to biggest in ascending order. Okay, so when we do that, smallest number there is 50. Okay, which is fine. That's gone. Followed by 55. That's gone. Followed by another 55. That's gone. Followed by a 63. That's gone. Followed by a 64. This is gone. Followed by 72 and another 72. They both gone. Followed by a 78 and a 79. That's gone, and then lastly the 89. Okay, so we must first arrange. Very critical to arrange the data set first. Then after arranging, we then are able to identify the middle line number. Since it's 10 athletes, okay, I know some people will go ahead and find the position of Q2 by using n plus 1 over 2. That n means the number of data values, so there are 10 of them, so we can say 10 plus 1 divided by 2, which gives us 5,5. In other words, it's 5.5. So the 5,5th position is basically where you would expect to find the what? The middle number. So if you count 1, 2, 3, 4, 5, right? 5 would be midway here. So you take these two numbers, right? And you say the median would then be equal to 64 plus 72. You divide it by 2. You take your calculator. You say 64. Is it 64? Yeah, 64 plus the 72. You divide it by 2. And it seems like the 1 is indicating that the answer for the median would be 68. Is that shared consensus? Are we all in solidarity with the 1 that the median is 68? Okay. It seems like people concur. People are saying yes. So please, guys, we do this. All right? Yeah. Okay. Then, next question. Determine the following of the data. Okay. So remember, median is called a measure of central tendency. There are 3 measures of central tendency. The others have not been asked in this, but had they been asked, when we talk about mode is the number that appears the most. Had we been asked about the mode here, we would have said the mode is, seems like there are how many modes in this data set? And we have what we call a mean as well. Mean is the average, the sum total of the data set divided by the number of data values. The mean as well is another measure of central tendency. All right. So we must know how to calculate or find those in the event that we are asked those questions too. Yes, Zito Kalanga, you are 100% correct. If we had been asked the mode, it would have been 55 and 72. We call that bimodal, meaning there are 2 modes, 55 and 72. Then there's mean. If we had been asked the mean, just don't forget, guys, we have this formula, which is x bar, sum of all the data values over n. We just use the calculator, we add those values, we write the sum total at the top over the number of data values, which is 10. We simplify, we get the answer. So it's formula, setup, substitution, answer. Formula setup, substitution, answer. That's how you would go about calculating the mean. I'm just mentioning those things, okay, because this question paper has not asked those questions. I just need you to know those things because that's a blind spot for this question paper. Whenever, guys, you answer past papers, always check for blind spots, because what you don't want to do is to be so hung up on a question paper and you think this is the question paper that you're probably going to ask, and then when you do what, you overlook the other aspects that are critical, and then when they come in the paper, you're like, oh no, what did I do to myself? And then you're the one that's crying. Anyways, range. What is range here? Maximum minus minimum. Okay, remember, range is a measure of dispersion. Okay, range and interquartile range are both measures of dispersion. Okay, so when we say maximum minus minimum, the maximum value is 89, the minimum is 50. So we say 89 minus 50, which gives us what? Very good, Zidegalanga, it's 39. Okay, simple as that. Range is maximum minus minimum. Interquartile range, okay, you can see it's 2 marks. So interquartile range will require us to find the Q3, because interquartile range is IQR is equal to Q3 minus Q1. Okay, Q3 means the upper quartile, Q1 means the lower quartile. Lower quartile, upper quartile, what are those things? If you look at your lower half of your data set, meaning from 64 to 50, there's 1, 2, 3, 4, 5 numbers. In these lower numbers, there's a middle number as well. The middle number of the lower half of the data set. So let's check what is that middle number of the lower half. Okay, the first 2 and the last 2 isolate 55. So that means Q1 is 55. That is our lower half. Q1 is the lower half of our data set. So Q1 is 55, not Q3. Q3 is the upper half. It's the middle number of the upper half of the data set. Q1 is the middle number of the lower half. Q1 is the middle number of the lower half. Please, guys, don't mistake or confuse the two. Q3 is the middle number of the upper half. So we go to the upper half numbers. These are the 1, 2, 3, 4, 5. These are the upper numbers, upper half of our number set. Okay, there are also formulas, like if you want the position of Q1, you can always use 1, you can say n plus 1 over 4. If you want the position of Q3, you can always use 3 over 4 n plus 1. Right, I just want you to note that for positional purposes, you can use these formulas. But, if you can identify them manually, that's also fine. All right, yeah. But I'm just saying, the position of Q1, n plus 1 over 4. The position of Q3, and I write P of Q3 because I want you to distinguish that this is the position, so that after that, you can actually then say Q1 is equal to, meaning it is now the lower quartile. Position of Q3, find the position first, then after that you can then say Q3 is equal to, after finding the position. Are we together, guys? So anyways, upper quartile 78. Okay? Then because there's the middle number of the upper half. 1, 2, 3, 4, 5. This is midway between these two and those two. So you say 78 minus 55. 1 mark for Q3, 1 mark for Q1. Final answer, guys. You'll be shocked and surprised. E23. That's the final mark that you get for interquartile range. That's a measure of dispersion. Interquartile range is a measure of dispersion. Okay, how spread out your data set is around the mean. How spread out your data set is around the mean. All your measures of dispersion are supposed to actually help us to be able to navigate how spread out our data set is around the mean. Okay, so we have what we call semi-interquartile range as well. Semi-interquartile range is when you take the difference of Q3 and Q1 and then you divide it by 2. Just so you note that, guys, because interquartile range is Q3 minus Q1. Range, maximum minus minimum. Semi-interquartile range, you take the difference of these two, you divide by 2. That's your semi-interquartile range. And the last question says, draw a box and whisker. Okay, diagram. In the diagram sheet provided, here's the scale, which is beautiful. They provided us with a scale. So guys, the beauty of drawing a box and whisker, and they've provided a scale. Isn't this beautiful? All right, now to draw a box and whisker, we need the 5-number summary. So we need to make sure we have all the values that pertain to that summary. 1, the minimum. 2, Q1, 3, Q2, 4, Q3, 5, maximum. So let's check what the values are. The minimum, the smallest value in that data set was 50. The biggest value was 85, if I'm not mistaken. No, 89. 89. 89, 89, 89. Q1 and Q3. Let's check Q1 and Q3. Q3 is 78. Q1 is 55. Then Q2 and the median was 68. So having all this data, box and whisker is ready to be sketched. So let's go and identify 50. Where are you, 50? 50 is here. Next, 55. Where's 55? So that's 1, 2, 3, 4, 5 here. 68 for Q2, 68, 70, 70, 69, 68. 68 is here. Then Q3, 78, 80, that's 79, 78 is there. And then lastly, maximum 89 was 89. 89 is before 90, that's there. All right. Then all I'm going to do is the whiskers, the box, and then the other whiskers. Okay. And that is min Q1, Q2, Q3, max, 78. Actually, no, sorry, 89. Why am I saying 78? 89, 78. Sorry guys, that like it's so freaking small there, like it's hardly visible that you guys can see it. I'm very sorry about that, but it's just that it is what it is. 89, 78, 68, 55, and last but not least 50. Or 50 is already there. Okay. Okay. Box and whisker sorted, covered. That is basically it. The whiskers, you use a ruler guys, box, minimum, Q1, Q2, Q3, and then the maximum. Okay. Right. I think now let's wrap it up with grouped data. Okay. Wrap it up guys. We need to finish off now. It's been a mean machine. The amount spent by K motorists at a petrol station just outside Moidrai at Sasselberg on a certain day were recorded as shown in the table below. Amount spent in X rands, okay, 0 to 50, 50 to 100, 100 to 150, 150 to 200, 200 to 250. These values, these are intervals. The amount spent in rands, okay, so that's between 0 and 50 rands. That's where 50 rands is included. Here 0 is not included. 50 to 100. 50 is not included. 100 is. 100 to 150, same thing. 150 to 200, same thing. 200 to 250, same thing. Then you can see here for each interval, this is the number of motorists that spent between 0 to 50 rand. Number of motorists that spent between 50 and 100. And so it goes, guys. You can see that. The first question that they ask is write down K, the number of motorists who spent money on the petrol station. The number of motorists who spent money on the petrol station. The amount spent by K motorists. So K motorists means a certain number, which is like, I guess, the total number. just outside Moidra at Cecilberg on a certain day were recorded as shown in the table below. So here the frequency basically talks about the number of motorists. So what we do is we are going to add the frequency values so that we can get the value of k. K will be equal to the frequency dot. Okay, so we add 5 and 9, 14, 14 plus 12, 26, 26 plus 15, 41, and then 41 plus 8. As we take Alanga says 49 motorists, and you are 100% correct. Okay. So we can say k is equal to 49. Okay, I don't know if there's any questions from that. I'd say that's pretty straightforward, nothing hectic. So you get your 2 marks for nothing hectic, but you added, which is cool. So 2 marks in the back. Write down the following, the modal class. Now, what is a modal class? Modal class is the class interval. So any one of these class intervals that has the highest frequency. So if you look at this, the frequency column, which frequency showcases the highest frequency, and therefore corresponding to that frequency, what is the modal class? What is the class interval that has the highest frequency? Which one is it? First, second, third, fourth, fifth interval. Which one? Okay, because we need to write down this inequality, any one of these inequalities that showcases the modal class. So you take along. Along is always answering. So yes, 150 to 200. Okay, not 209. Be careful. Yes, I see that. So that's the correction. So take note, highest frequency, corresponding class interval. That's the highest. That's the one. Okay. 2 marks. 6.1.2. The class in which the median lies. Now, this one needs us to basically have what I call the frequency, cumulative frequency. We need to add the frequencies in a cumulative fashion. So if we do that, let's say we had a cumulative frequency column, and this stays as 5. But if you say take 5 and you add 9, you get 14. You take 14, you add 12. For this row, you have 26. 26, you add 15, you get 41. 41, you add 8, you get 49. So this is like the cumulative frequency column, if you would say, in a sense. And yes, this is basically a concept only covered in grade 11, cumulative frequency. But the idea of cumulative frequency is something that we use to be able to determine the class interval in which the median lies. How? Well, if we're going to say position of Q2 and sort of like use n plus 1 over 2, that n plus 1 is going to be the 49 plus 1 divided by 2, which is actually 50 divided by 2, which gives us 25. So what we do then is we're going to add the values of the frequency column in a cumulative fashion until we'd add the values of the frequency column in a cumulative fashion. But since we have the cumulative frequency, what we are going to do is we are going to we are going to go and identify where 25 is reached or slightly exceeded. It's not reached. Because we're going with a cumulative frequency. It's not reached. It's slightly exceeded. Because it's either you reach. If you reach first, we stop. Or if you slightly exceed first, we stop. So it depends which one comes first in the situation given. So 5, not reached. 14, not reached. 26, okay? That means the first thing that happened is us slightly exceeding. So this is where we stop. Then locate that class interval. So that means the class interval in which the median lies is actually 100 less than x less than 150. That is the class interval where the median lies. X is greater than 100 but less than or equal to 150. Any questions, guys? Okay. If they said they want the estimated median, then we would just simply find the midpoint of the class in which the median lies to then give them the estimated median. Estimated median is simply the midpoint of the class interval where the median lies. I repeat, estimated median is simply the midpoint of the class interval where the median lies. So had they asked for that, we would have comfortably been able to find that. Okay. Right. So I hope you get the point. We stop where if we had reached exactly, we would stop there. But since the first thing that happens is us slightly exceeding, we stop where we slightly exceed. So we stop where either reaching or slightly exceeding happen first. Whatever happens first, that's where we stop. Okay. So in that situation, it is when we slightly exceeded that we actually are going to stop. So that's why we stopped in that particular interval. But this is for when we have the cumulative frequency. You do that with you go exactly where we reach or slightly exceed. Okay, take that class interval in that row and then write it down. Okay, that's the class in which the median lies. Lastly, the estimated mean. How do you calculate estimated mean? We need 2 additional columns, one for midpoint, and then the last one for frequency times midpoint. Okay, so midpoint first. How do we get midpoint? We say 0 plus 50. It's like we add the lower class and the upper class of each interval and we divide by 2. So 0 plus 50 is 50. 50 divided by 2 is 25. 50 plus 100 is 150. 150 divided by 2 is 75. 100 plus 150 is 250. 250 divided by 2. 100 plus 150 is 250. 250 divided by 2, 125. Yes. If we had the accumulated frequency of 24 and 26, we'd still take 26 because 26 is the one that slightly exceeds. 24 does not reach. So we still continue, all right? Yeah, because it's either the one that we reach or slightly exceed, my guy, okay? That's where we stop, okay? 150 times plus 200, that gives me 350. 350 divided by 2. That's 175. 200 plus 250 is 450. 450 divided by 2 is 225. Then what do we do? Frequency times midpoint. That means the frequency we multiply with the midpoint. You guys need to tell me what the first value is. I'm gonna wait for you guys. You tell me. If you say first, second, third, fourth, fifth, when you write down in the comment section. 5 times 25, 125. Thank you, Zite Kalak. 125. Write with a different kind. Thank you, Zite Kalak. 125 is the first multiplication. Nine times 75. 9 times 75. 9 times 75. It can't be Can't be 902. Can't be 702. No ways. 9 times 75. 9 times 75. Can't be 702. No ways. Thank you, Zutagalan. 66675. 12 times 125. Thank you, Lisha. Thank you, Lisha. Really appreciate you. Appreciate it much. 12 times 125. Frequency times midpoint. 12 times 125. Thank you, Zudagalanga. 1500. 15 times 175. 15 times 175. Thank you guys for the calculator work. I really appreciate it in the comment section. You guys are doing the most. Too much love for you guys. Much respect. 2,625. Thank you, Zitagalanga. 2,625. Then last but not least, 8 times 225. Wow, it's after 1. I can't believe it. I'm still up. What the freaking doodle, man. 8 times 225. Thank you, 1,800. Okay, then I need you guys to add this frequency times the midpoint total. Okay, because I'm going to need it to calculate the estimate mean. And I'll explain what do you do to get the answer. For the estimate, they don't ask here for actual mean, they ask for the estimated mean. Okay, so you add everything. 125 plus 675 plus 1,500 plus 2,625 plus 1,800. You tell me what the total of the frequency times midpoint is. Thank you so much. Wow, Lisa, thank you so much. You guys are such stars. Like you guys are such stars. Thank you so much. Really appreciate you. 6,725. You guys are stunners, man. Love you guys too much. Lady Bablicious, thank you so much. It's 6,725. Okay, so now we want to calculate the estimated mean, guys. This here, the sum of the frequency times midpoint total together with the sum of the frequency. These are the aspects I need to calculate the estimate mean. So the estimate mean will be the sum of the frequency times midpoint over the sum of the frequency, which you can then go ahead and write 6,725. You divide that by 49. As you can see, guys, sum of the frequency total in the denominator, sum of the frequency times midpoint in the numerator. Then you punch that into your calculator so that we can get the mark. Okay, I know some people, they simply stick to sum is equal to the sum of all the data values x. Okay, and then they basically utilize that 6,000 over n, and they use that 6,725 divided by 49. I mean, I think that's also fine. What do you guys get as an answer? Remember, there's no specifics as to how we need to round off, so we need to make sure that we write our answer to decimal places. We revert back, so it's 137,24. So it's how much? It's money, this one. Yeah, it's money. So we need to specify the rands. Kimali. Okay, 137 rand, 24 cents. If that is basically, oh my soul, what's happening? 137,24, 1,37,449. Now who's actually giving me the things here? Is it comma 2 or is it comma 4? Remember, guys, I don't have a calculator. I'm trusting that you guys will give me the correct answer there. So 6,725 divided by 49. Okay, I'm trusting you to help me get the correct values. So Lady Bablish is saying comma 449. Uzvitekalanga is saying comma 244. Can you just verify for me, guys, which one is it? Is it comma 2444 or is it 137 comma 449? Which one is it? Because one is definitely not giving me the raw deal and the truth. Come on, guys. 137 comma 245. Okay, so it's definitely comma 2. It's 24 then. It's 137 comma 24. No problem, lady. No problem. That happens. So yeah, 3 marks. Formula substitution. And of course the answer. 137 comma 24. Third mark. Okay, no problem. Then draw a histogram for the data on the grid provided in the diagram sheet. Remember, a histogram, guys, is drawn using our frequency. Okay, so the amount spent in rands. Remember, 0 to 50. Okay, so that means our histogram, our first frequency is 5. 0 to 50 is 5. So we come here, 0 to 50, 5. So 5 is between 6 and 4. Okay, you use a ruler, of course, guys. Make sure the bars are straight. You get the point. I'm just freestyling now. It's just 9, 50 to 100 is 9. So 50 to 100, 9. Sorry, guys. I wish I had one of those straightening of the line kind of apps. It would make life so easy. 50 to 100. We'll get there. 100 to 150 is 12. 100 to 150. Straight lines, hey? Please, guys, with your ruler. Don't do what I'm doing here. This is really freehand. 150 to 200 is 15. 150 to 200 is 15. 150 to 200 is 15. 15 is between. Okay, and then lastly, 8. 200 to 250 is 8. Okay. The title is already the amount spent by the motorists at More Dry Filling Station. The number of motorists is also taken care of. Okay. Okay. Guys, that's it. Okay. Labeled y-axis is already labeled for us. Labeled x-axis, amount spent in rands. And then you see the spacing out in the x-axis. 0, 25, 50, but we know 0 to 50, 50, 75, 100, going up in 25s. It works out nicely. The bars of the histogram are equally spaced. So 2 marks here. Bars correctly, tightly packed, and equally distributed, which is sweet. Okay, guys, that finishes this paper. We draw the histogram for the data on the grid provided in diagram sheet. We did that very well. Okay, that's all for me, folks. Yeah, I need to sleep. Hopefully I get enough rest so that I can be productive this morning. So I'm gonna try and upload this on the YouTube channel. You guys, please can go and subscribe to my YouTube channel. Guys, can you just go to my YouTube channel and really, can you just like the videos? Like, even if you don't like them, just like them. I just need some buzz and activity in that YouTube channel, guys, because we need to get it to that place. I know maybe quality videos are not the norm there, but we'll get there eventually. So the link to my YouTube channel is in my bio. Please support a brother here, guys. That would be generously appreciated, because remember, lessons here or whatever sessions I do here, I mean, I'm doing it for free. Nah? So please, just if you can just help support me just by going to my YouTube channel, subscribing, and then just liking the videos, commenting where you can comment. If there's something that you can listen to, whatever the case may be, please guys, just activity in that channel would be really appreciated. Otherwise, thank you so much. The YouTube channel link is in my bio. It's also called Maths is a Game. 5 to 7. Profile picture is white. It's got Maths is a Game. Let's play. Okay. Thank you so much, guys, for joining in, and I'll see you again, great times, on the next exciting episode of whatever, when we do meet again. Thank you so much for joining in. I hope this was really beneficial, that you guys gained a lot as we went over these questions and you picked up a thing or two. Okay, good night now, guys. Please sleep well and take care. Lady Publishers, thank you. You are welcome. You're welcome. You're welcome, welcome, welcome. And your gratitude, your heart of gratitude be doubled over. All right? Yeah, may a portion of much more many blessings be given to you. Oh, is it? Oh, wow, that's awesome, lady. You're learning your GSCE UK. That's great. Oh, wow. Okay. What an honor. What an honor. What an honor, Lady B. Aye. Good for you. Big up to you. Keep it up. Enjoy. Hopefully you are able to achieve your intended goals and your objectives by actually doing that. That's big up to you, lady. You're welcome. Are you super welcome? It's my pleasure. It's my pleasure. It's my pleasure. I appreciate internationally renowned viewers that are doing maths courses in other realms. Epic. Okay. Well, let me be off. Good night, guys. Good night.